Okay, let's make an SLM. They're called hyper because they're set before training, where model parameters like weights are used during training. That's good to know. These define the shape of our neural network. Okay, so unique tokens that it can use. This determines the different words the model knows. Okay. In size, this is the width of our model. How many numbers represent each token? More capacity to represent complex patterns, but still have more memory. Number of blocks, this is the depth of our model. How many times we transform the data. Okay, and then heads are the attention model heads. Attention heads let the model focus on different aspects of the context simultaneously. One head might learn grammar, another might learn semantic, blah, blah, blah. Okay. Okay. Feed forward network dimension, learning after attention. Each position goes through a small neural network, typically 4x the model dimension, where this is parameters are live. How many tokens the model can remember at once. Context, blah, blah, blah. Dropout float, dropout rate for regularization, randomly zeroes out 10% activations during training. Interesting. Okay. Okay. Batch size, number of sequences per training step. How fast the model learns, too high is unstable training, too low equals good fit for transformers with atom optimizer. Number of training steps, one iteration, one forward pass, backward pass on the other. Learning rate warm-up steps gradually increase the LR at the state. Weight decay. Penalizes large weights to prevent overfitting. ... Use Apple Metal Performance Shaders. Yeah, I'm using an M4 Mac. Okay. Use control text diversity. Okay. Pretty print the configuration. Break down the parameters here. ... Embeddings. Create the model config instance. Okay. Yep, please do. Checkpoints, config, that's what we've got. Hit ignore. This is our README on how we're going to go about it. And then we're adding requirements.txt slowly and surely. Don't call me Shirley. We'll be fine. Tokenizer model. Tokenization, text is continuous, but neural networks work with numbers. Tokenization is the bridge between text and numbers. We break text into pieces and tokens and assign each part a unique integer ID. Hello world becomes hello world. And then this is that. Manage use characters. Words are better semantic units, but there are too many words. Subword tokenizations like BPE finds a good middle ground. Okay. Byte pairing coding. Start with individual characters and bytes, find the most common pair of tokens, merge them into a new token, repeat until you have your desired vocabulary size. Example, low, 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 lower. Step 1. Step 2. Step 3. Pair result, low, 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 low. Handles unknown words, can break into subwords, common words, single tokens efficient, rare words, multiple tokens still representable. And fixed vocabulary size. Initial tokenizer, which BPE encoding to use. We're just going to be using the GPT-2 tokenizer. All tests are widely used, good balanced vocabulary size, work with English text. We don't have to train our own BPE, that would be very complex. Word text and token IDs. I've done very similar stuff to this when we were working on our NGX, paperless NGX system. Cool. Cool, cool, cool. Tokens back to text. Integer tokens, encode batch. Demo tokenizer, demonstrate how tokenization works. Learning exercise, run this in the BPE section. Examples, quick brown fox jumped over lazy dog. Tokenization breaks it into pieces, blah, blah, blah. Okay. That's fair. That's fine. Yo, doing a random impromptu live over on YouTube where I'm also the giant. Come check it out. We're learning how to build our own small language model today. Yo, doing a random impromptu live over. I had to tell my wife where I was at. She was like, "What are you doing?" Throw that up on my end real quick. What am I looking for? Chrome. Maybe later. I don't want to. Chrome. Please. Thank you. Cool. Sorry about that. Transform is a neural network architecture that processes sequences like text using attention mechanisms unlike RNNs, which process tokens one at a time. Transformers look at all tokens simultaneously. Innovation is attention. This model decides which parts of the input are important to focus on. The file builds a GPT-style decoder, only transformer from scratch. Okay. Multi-head self-attention. What is attention? Imaginary distance. The cat. I sat on the mat because it was tired. To understand it, you need to look at the cat. Attention does this. Mathematical intuition. This is what I was obsessing over while drunk. Cool. Query, key, and value. And then your softmax. Cool. Quirky value. How much should each word attend to every other word? Scale by delta. I don't. What's that stand for? Oh, square root of the value. Okay, we're divided by the square root of what? Okay, we're going to use a different tool real quick and ask it a quick question. Elaborate a little bit further. You see the D, attention is the softmax of this. The D stands for dimensionality of key vectors, often read as D sub K. Your key query vectors each have, say, 64 elements, or their dimensionality is 64, then you divide 64. Okay. So it's dividing the dimensionality. D stands for dimensionality. Dividing D, the dot processes. Okay. So we're going to do else. Open up another Claude real quick and be able to have it edit some of that down for us. Like, oh, thanks. So I think it's a cool lo-fi option too. A multi-head, like having multiple perspective. One head might learn grammar, other semantics, blah blah blah. Okay. Information to mix. Casual master auto-regressive generation. We prevent the model from looking at future tokens. Cheating. Position. I can only attend to positions greater than where I'm currently at. Okay. Step 1. Project Q, K, and V. Batch sequence. And reshape for multi-head. Batch. The dot, the dot, the dot. Compute. K2 with scaling. Learning. We scale the dimensionality head to keep variance stable without scaling. Dot products grow the dimension of softmax saturates. Apply casual mass. This is crucial for language modeling. When predicting token I, we only see token 0. Softmax to get attention weights. Apply attention to values. Concatenate the heads of the project. Feedback network. Position wise. Feed forward network. What does it do? After attention mixes information between positions, we need to process each position independently. This is simple 2-layer neural network. Feed forward network inside a transformer block. Input vector, weights and bias for the first linear, weights and biases for the second linear layer. Activation function, Gaussian linear unit. Multiply the input by blah blah blah. This extends from 512. It's like saying let's blow this small representation to a rich internal space. Apply that which is smoother than ReLU. Intuitively, small negative values get dampened, large positives pass through but softly. Okay. Can you explain this to me differently? Question mark. I am big dumb. The attention layer. Now your brain needs to go and think what it heard. That's where the network comes in. Model takes your current thought X and stretches it into a bigger place, like writing your idea out in more detail on a whiteboard. You get more room, blah blah blah. Be smart about what matters. As a fancy filter, it softly decides which parts of your expanded thought are worth keeping. Okay, so does this mean the feed forward network is like human salience? Works on each word individually, taking the raw mixture from attention, analogy time with attention and awareness, looking for all the room. Then is reflection, deciding on what it's doing. Interesting. That's so cool. I mean, I would like to validate this with a different tool or different quick Google, right? Let's see. Is feed-forward network similar to human saliency? Huh. Interesting. Oh, cool. Okay. YGELU instead of RLU. We're going to use the Gaussian error linear unit. It's a smoother than RLU and works better for transformers. It's like a soft RLU that doesn't have a hard cutoff. I expand the 4x dimension. The first layer expands to DFF, typically by creating a bottleneck architecture. This is what most model parameters live. Okay. Transformer block, a transcendental former block. Layer norm, multi-head attention, residual connection, layer norm, feed forward, residual connection. Okay. While layer normalization normalizes inputs to have mean 0 and variance 1, this stabilizes training in deep networks applied before the sublayer pre-LN variant. While residual connections allow gradients to flow directly through the network during backup. Okay. Okay. The full transformer model, complete transformer language model, the full pipeline token embedding, convert to ID, positional embedding, add position information, transformer blocks, process sequence n times, layer norm, final normalization, output projection, map to vocabulary units, positional embeddings. Attention has no notion of position. It's a permutation invariant. We need to tell the model this is word 1, this is word 2. Original paper used sinusoidal positional encoding, but learned embeddings work just as well and are simpler. What's that mean? What's that word mean? Up and down repeating pattern is a sine wave. Just fancy memory of the way of saying a drawing with a smooth wave shape. So when something is, it moves wave-like rhythmic pattern. Okay. Cool. Yes, we want to create that file. Cool. Let's create the data loading pipeline now. Post a YouTube link to our developers. Oh no. Why? No! Maybe. That would be cool. I don't. Thanks, baby. Hopefully, no experts come in and start bashing me over the head on the fact that I'm using an LLM to explain how this works. We'll see, though. We shall see, though. Like, what's up? Okay, data.py. Where are you wanting to create data.py? Where are you trying to make that though? Okay. Yes. Please make that file. How do we prepare text for training? Large language models learn by predicting next token. We need to load raw text data, tokenize it into numbers, split into training validation sets, and create batches of sequences. Casual learning language modeling for each sentence. We create input target pairs where targets are shifted by one. The cat sat on the. Model learns given token 0i, predict the token I plus 1. Data set for casual. PyTorch data set is a container that stores data, blah, 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 blah. Learning, we start a sequence at any position except near the end. Okay. Load and tokenize text data split into train eval. And we've got the arguments, data path to text file or directory, returns, blah, blah, blah. Validation data should never be used for training. Cool. Create PyTorch data loaders. What's a data loader? Data loader wraps data set and provides batching, group multiple samples together. Okay. Attention mechanism. Once upon a time in the land of deep learning, there lived a powerful concept called attention. Attention changed everything. Before attention models could only remember short sequences, they would read text from left to right, one word at a time, forgetting what came before. But attention was different. Attention could look at all the words simultaneously. It could decide what words are important, which would be ignored when processing it. Attention could be looked back on the concept. This revelation is blah, blah, blah. And so attention mechanisms lived happily ever after, powering models like GPT, BERT, and beyond. And why transformers work? Because of the three key innovations. First, self-attention, each position to aggregate information from all other positions. Positional embeddings give the model a sense of order. Third, the feedback networks provide per position computation. After each, the future of language models, large language models are becoming increasingly capable. They can write code, solve math problems, solve limitations, hallucinated false information. Future research will address these challenges. Blah, 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 blah. Okay. And then we're gonna make a train.py for the training loop, I'm guessing. Training is the process of adjusting model parameters, weights to minimize loss. The forward loop, forward pass, make predictions, calculate loss. How wrong are we? Backward pass, compute gradients, how to improve, update weights, take a step in the right direction, repeat. One pass through the entire data set, iteration steps, one forward, backward pass on the batch. Gradient descent, follow the slope downhill to minimize loss, learning rate, how big of steps to take. Wire app training a class that organize related code, maintain state, easier to extend, add features without changing function signatures. Torch.compile optimizes the model graph for faster execution and traces the computation, applies optimizations like kernel fusion. Oh, okay. Parallelization, kind of. Or threading. Setup optimizer, weight decay, MW optimizer, most popular optimizer, combines adaptive learning rates per parameter, momentum, okay. Learning rate scheduling, gradually increasing LR. Learning rate with warm up and decay, learning rate schedule, warm up 0 headers, okay. Cosine decay, warm up headers to max iteration, smoothly decrease cosine curve while else fine tuning in later stages. Forward pass, compute predictions and loss, backward pass, compute gradients via back propagation, gradient clipping, prevent exploding gradients, optimizer step, update weights, 0 gradients, clean for next iteration. Okay. Training loss goes down. What is the model? Generalized validation. Loss tells us for overthinking. Train loss. Val loss. Good. Models learning. Train loss. Value loss. Overfitting. Model memorizing. Both high. Underfitting. Need more capacity. Okay. Main training loop. Reiterate over the data set multiple times. Epochs. Updating weights for each batch. Periodically we evaluate certain data and save checkpoints. Loss should decrease over time. Perplexity. Blah 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 blah. Training complete. What are we going to train this on? Okay. Load train model from checkpoint, blah, 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 main generation, maximum tokens to generate, top case. So this is like setting the weights and values for like Gemini or any of the other tools when you were able to. Nifty. Okay. And a getting started guide. We're gonna do a get started guide? I like get started guides. Oh, thanks, man. No, I'm not upset with you posting that, or I'm not, like, not an issue. Oh, thank you, baby. Okay. So it's giving me a get started guide. We'll go ahead and walk you through the building and training your first small language model. Project is designed to teach you how they work by building one from scratch. Each file contains extensive comments explaining the concepts, see how tokenization works, understand the model architecture, read the code in this order, train your first model, generate text, installation, training, running will create data for you. Okay. Tell dependencies, create simple training data. Save checkpoints to checkpoint, show training process. Training loss should decrease steadily. Perplexity, losses, nan. Next steps, experimental generations, okay. We're gonna create that. Now I guess we're going to go and figure out what we want to train this off of. Let's see. All conversations Iron Man has had in the comics as a text file. Iron Man quotes. curious what it'll do. Let's see. Mark everything complete and create a final document. Let's see. Large language model. The language model learns the probability distribution over sequences, words or tokens given the text. Convert text into numbers, convert numbers into vectors, process vectors. Why not use words directly? Yep. Python token embeddings, embedding learn. Attention mechanism, the core innovation. When processing a word, look at all previous words and decide what's important. Okay. We've read through all of this before. Let's see what it does. Okay. Doing a project overview. Of course. Using the wrong Python script because we use Python 3. I don't think that you actually went through and installed on the dependency. Yeah, okay. Let's create the final setup. Script and summary. Yeah, I don't know why you tried to run. Okay. Doesn't matter, you're an AI. That's why you tried. I do the same thing though, so I can't really be upset with you, buddy. Okay. That's just going. Okay. Got. What's it got? But it needs the training data. Let's try it. Okay. Please. Thank you. Let's do... create the Vim. Activate it. Okay. Installing all the required stuff. Let's see. No. Cancel. I don't want to move those anywhere yet. These are going to go into data, not there. Move. Yes, please. Thank you. That's still installing the packages. Actually, we are going to use it in this repo as training data. Make sure it follows. It's formatted properly for the code base, question mark? Yes. We're gonna try it. And then next steps over here again. It's there. And there. Cool. And then those are all set. And then we'll validate. I don't. Testing device, test pass, ready to train. Testing imports, available tensor operations work. This is a test. Loaded, test. Transform, model created. Test pass, torch size, loss, works, test pipeline. Test sample. Okay, so this is the test sample that it got. Okay. So it's using this test sample.txt that it generated. Let's search this code base and see where else test sample, please. Okay, so it's only, it prepares that data set for that test specific. It's the only spot that actually comes up. Cool. Train.py. Test. Oh, test. Data slash Tony Stark training.txt less. Okay, cool. So then we're going to try to run the training directly. Oh. No model name config. Let's see here. it doesn't have a model config. It's got a model underscore config. From config model config. So that makes me wonder if from config model import model config. So this is where it's supposed to be pulling it from. But config underscore model config. Is it because this is all commented out? We're gonna throw that there, and I'm going to go and do a bio break real quick. Oh. If that's why, okay, that's wild. Cool. Weird. Ooh, my Mac is getting hot. Okay, so now I think that the part's just going to be boring, and it's just going to keep going and do the thing. This is like the best part of any form of development, is just waiting for the code to run and compile and stuff. Yay. Epoch started. So it's got to do this how many times? I think we do 64 epochs. The loss went down. It's doing the thing right, yo. Let's go. No, the lag on stream is because I am currently training the SLM using my Mac and also trying to stream from my Mac. Let's try closing a few things. Let's see if it gets any better, maybe. But it's glitching on my end too. Let's see what my system resources are. Disk having a little bit memory. Okay, Python is eating up 25 gigs of memory while it's doing this. Holy shit, that's insane. Oh, it crashed. No. But now the audio should be back to getting caught up. It failed. Why it failed? Wait, where should it be getting the validation data from, I wonder? Wait, QQ, what validation data should we have? If this was to teach, should we have something else for it to use? I don't know. Okay, so that makes sense as to why it crashed based off of that, but I'm still confused as to what, like, are we supposed to be using validation data from something else? So if I use Shakespeare to validate Tony Stark, would that not just have validation being off every time? Question mark? I don't know. I don't think it ever even got to a checkpoint because of that. Think of it like... Yes, okay, correct. That's what we were... Okay, good to know. Just need a bigger data set in general, and that validation worked the way I was thinking. Could you retrieve Tony Stark quotes data set somehow? Question mark? I don't know if it can or not. I doubt there's an API that has Tony Stark quotes to pull from Claude. I don't think that exists, buddy. It found something. What did it find, I wonder? I mean, it did essentially a Google search, so of course it's going to find something. I wanted to talk like Iron Man. Like, I'm not, this is not going to be used by anyone else other than me. I just want to, I want to, like, make an Iron Man LLM or SLM that lives on my machine, and it's just fun to do. Thanks, Lulu. Okay. Okay, making the data steps, the training steps lower. We only need to do it a lot smaller. And then it's also cutting that down even smaller. Good. Yes. You know what? It's giving that error about MS. I'm curious why that is. Let's see. Okay. Nothing to worry about, supposedly. We'll see. We'll see. So this is going to be compiling for a minute, and if the audio starts getting glitchy, I am sorry. Let's throw the activity monitor up, and we'll watch for the glitchiness to start. Oh, glitchiness is already starting. That's great. Epoch 1 had loss of 9.9. This has loss of 8.6. Cool. Epoch 3 8.2 so far. I actually got down to 7.3 for the Epoch 3. Cool. Oh, step 100 of 2000. Woof, okay. This is gonna be going for a minute, y'all. It's just going and going and going. Losses are getting smaller and smaller. Yay. So did that make us a new? It did. And that made another checkpoint, question mark? No. Step 2 out of 200 out of 2000, so we're a tenth of the way there, guys. 10th of the way there. Crazy. Thanks, Lulu. Whoa. Okay. Training loss went down. Step 300 out of 2000. This is going. Going. Guess while this is just spinning. I don't know what to do. Wow. A lot of epochs left. Making our own chatbot. And it's going. I can't wait until it's done trading so we can mess around and try to, like, chat with it and stuff. Make certain to like and subscribe and stuff, anyone that's new to the channel. I'm a weirdo that does weird things and just chases the dopamine. Gotta chase the dopamine. Gots to chase the dopamine. HCL. Okay, let's try to make our own chatbot. We're on Epoch 21, step 500 out of 2K. And this is all happening, including the stream, by the way, on a M4 Pro 48 gig. 48 core. So what we're currently testing around and doing stuff with. Oh man, life is good today. It's been a rough couple of weeks, yo. Hope everyone's staying safe. So currently, anyone that's just now joining, we are actively training this small language model based off of an educational data set. We're not doing much validation training because we have such a small data set specifically. But this is all vibe coded with Claude, and we are trying to learn how language models are generating data and how they are trained. And that's where we're currently at right now, is training it. Training the model on Tony Stark text, a very small amount of Tony Stark text. And the idea here is if we're able to use a small amount of Tony Stark text and get it to actually respond kind of the way we would assume Tony Stark would respond, that means you could easily take the texts that you've sent to people, the emails you've sent to people, your own writing, and on your own machine train an LLM or an SLM that talks exactly the way you do, or a close enough approximation. And that's what we're hoping for here, is to create something that allows us through this learning to spit out text the same way you would, instead of teaching ChatGPT or paid services how to sound like you, and then you still have to go back through and figure out how to get rid of EM dashes and stuff like that. You just train your own model on your own hardware to talk exactly like you do with your own training data. Ignore the fact that I look like a crazy person with wild hair right now. I mean, or don't. Kind of is who I am, so. We'll see. Step 800 out of 2,000. Man. This would be a lot quicker if we had more compute. But we don't. We have a very nice machine. So this might take even longer on lower tier computers or whatever. But it would still be able to get done. What have we got? Okay, that's been sent off. That's what we're doing here. $900 out of 2,000. We're making progress, y'all. Man, I need to figure out something to do with my beard. Pulling at it if I don't. So we'll see. Thanks, Lulu. That's awesome of you. 1,000 out of 2,000! Yay! So, anyone here playing like the new Pokemon game or Outer Worlds 2? Because I've been obsessing over Outer Worlds 2 the past few days. And Pokemon A to Z latched on pretty hard until it came out. But once Outer Worlds 2 hit, I kind of abandoned Pokemon for a little bit. But if you are an older Pokemon fan like I am, I think you might enjoy A to Z. Check it out. Give it a look over. Oh. Okay, that was just it switching songs. Not doing anywhere near as much work for it, so let's see. Bad hand. Stop it. You really got to stop it, yo. Any other developers out there have like typical go-tos that they'll do while they're waiting on stuff to compile or train? Because like I will often just like continue to read through the code base that I'm living in at the time, but for something like this where the code base we've already read step by step how it was going through and it's all new, like I need to wait a minute before I re-expose anyways. So what do you just like start playing games? Do you find something else to occupy your time? I know Kaparthi was talking about using dictation for all of his code so that he can go through and like do other things and then just dictate anytime he needs something else made. But 1,100. 1,100 out of 2K. We're getting close. Oh man. Spotify? You okay, buddy? Did you die? What happened? Why are you pausing? I don't want you to be pausing. I don't like that. I don't like that very much. Okay. Definitely a keyboard interrupt. 1,200 out of 2,000. Okay. Training loss is getting tinier. Well, actually. Huh. at step 900.02, and then step 1000 was 0.0166, so the training loss went up and then started to go back down. I guess. We'll see. We shall see. That's peculiar. Okay, and then it went to the lowest point that it's been at. Repuck 1300. Or 100, I mean, not Deepuck 1300. That would be insane. What in the world is happening here? Okay, I guess we'll look over what the next step is after we run the... code, study learning guide, day 2, first training run. Perplexity should be going down. Perplexity is going down. Learning rate follows the schedule. So after this, we can actually test generating. Golly, so this could just be like iteration over iteration over iteration for the models over. So you would train, test, tweak parameters, train, test, tweak parameters, train, test, tweak parameters. Ooh. But it seems like the validation loss is starting to be a little sporadic, but it got minimally better. So it's still occasionally decreasing for Epoch 54, I guess? I don't know, that's weird, man. That's weird. But it's at 1500 out of 1200, 2000, so... Oh man, I'm so excited. We're getting closer and closer. Why did it make a notebook if we're not going to have notebooks? Yeah, it's not getting any better for training loss. I'm afraid to stop it right now though, because I don't know if it's actually generated enough of a model or not. And I don't know how to open up PT files on my machine yet. So we'll be figuring that out shortly. But I don't know, yo. I don't know. $1,600 out of 2,000. We're getting closer, y'all. We're getting closer. Am I losing my hair? Am I going bald? I'm afraid I'm going bald. $1,700. Block 63. Getting closer and closer and closer. And this is, of course, like the bare bones doing it yourself from the get-go type thing. I'm fairly certain that you could have a easier time and a faster time if you were to just like use some of the models that allow you to train the weights of the existing model yourself. Like Amazon has one, I believe. Bad hand. Stop it. Yeah, Amazon SageMaker. So you could probably use something like that and train a much more powerful system yourself. $1,800! We're getting closer. The loss is about as small as it's going to get, I guess. Perplexity's been generating around like 1.01, 1.02 for a while now. Bad hand! Stop it! Man. $1,900. We're so close, y'all. We're so close. We are so close. We're about to be there. We're about to have it. Guys, we're so close. Let's see. Oh, what? We are so close to there. We are close. This should be the last epoch, I believe. Oh, no. We had another epoch. 72. Final validation loss, best validation loss. Okay, so now in theory we can just do this. We use this, paste that there, and then let's do prompt, and then let's literally just say Piper, and then do, let's leave max tokens open. Okay. Why? PyTorch will change the default value, waits only argument from false to true, rerunning the torch load, check the documentation to see how accepted, blah 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 blah. What's Claude got to say about this? I see the issue, torch load, but your checkpoint model config class is allowed to default. Let me check generate file. Fix the issue by adding safe globals for loading the checkpoint. Torch load. We also need to fix the issue in training where the checkpoints are loaded. Okay. What have we got here? Unexpected keys. So, what's this mean? Let's see what that means specifically. Okay. Okay. $76 million parameters, generating text, settings. I just said Piper. I but this, his, and to, his, and eyes on symbol tilt. I has picked captain. This is what? That's weird. It did not even sound similar at all. Does it have the same generated text every time? $72 epochs, 0.01, 5 smallest training loss. Training data set is the Tony Stark txt. Piper and IU. Okay, interesting. His and Avengers. So let's try this. We have this. And instead of doing Piper, let's do priorities, because we know about priorities, no amount of money ever bought a second of time. Yeah, this is making me think that the training was messed up. Dataset's too small, very limited vocabulary, repetitive patterns. I has etc. Quote heavy from training. I am Iron Man is too powered up. I don't need this. The model learned quotes. Punctuation. Loss of doesn't mean good generation. It just means the model memorized the training data token sequences. Okay, so this is way too small of a data set, is what I'm hearing. That also means that training would probably take a lot more. Um, please help find larger data set on Iron Man. Let's see what happens here. Does this data set actually exist? Okay, so it's suggesting we use this massive dialogue data set. I haven't used Kaggle in so long. Dismiss, download the data set, archive.zip. So we downloaded the entirety of the MCU's dialogue data set. Okay, make it all into one file. Claude messed up again because it forgot. And then that messed up. Encoding issue. Do it again. Okay. Get rid of the old checkpoints funnel model, blah, blah, blah. Make it disappear. We'll see. Tweak the training files so that it can use the majority of the max ability. Let's do it. So the training steps are going up significantly. Okay, so I'm going to get this start training and then I'm going to stop streaming for a bit and go off until this actually finishes, and I will return once it's finished and update everyone on how it's going. But this is going to probably take hours, so don't want you guys to just have to chill and watch thing generate. Okay. So this is gonna be a minute. Dang. Alright, y'all. I'll be back. But stay safe. Bye.